Welcome, 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 welcome. We're in section 1.6b, fresh off of 1.6a, where we learned about interval notation. So as we're working through some of these problems here today in this section, we'll try to include the interval notation in that, okay? Our objective in this section is, number one, to solve compound inequalities, and number two, to solve absolute value inequalities. All right, first of all, compound inequalities that use the word and. First of all, these inequalities are only true, you're only going to graph the sections where both inequalities are true. So in other words, their graphs have to overlap for you to graph it for the overall thing. Okay, so I've broken it down here, and we see that, first of all here, x is greater than -4. So here's -4 on my graph for all of these. Greater than or equal to means we're going to go open circle, but then we're going to fill it in. Okay, so filled in circle. Greater than -4 means I'm going to do to the right. So it's going to look something like that. Okay, by itself, x is greater than -4, greater than or equal to -4 would look like that graph. All right, now I'm going to do something really cool here. I'm going to change to red, since I've got this other one in red. So now here for x is less than 3, less than, no equal to, on this graph, it's going to be an open circle. And since it's less than, that means it's going to go this way. Okay, so by itself, x is less than 3 would look like that red graph there. All right, and now one more time here, I'm going to change this to black. Okay, so now when we put the word and in here, x is greater than or equal to -4 and x is less than 3, we only graph the part where these two graphs by themselves overlap, where they overlap, in this middle part here. So when we have these together, how I have to do this is I put a filled in circle there on -4 because this one's filled in. I put an open circle on 3 because that one's open. And where do they overlap? Not out here, not out here, only in the middle. So I'm only going to draw my line here in the middle. So together, your inequality when it's an and would look something like this. Most of the time they're going to look like that. You'll have some strange situations every once in a while that might look a little different. So keep this in mind here, that the graph of the solution set is the intersection of the two equalities. Again, that means where they overlap, as I said there. And keep in mind now, if you get these where they do not overlap, if there is no place where those two graphs overlap, there's no solution. Okay, so keep that in mind. All right, let's look at an example here. The way this is written, and I think I mentioned this in 16a, this is an and. Whenever you do not see the word and, but you've got two inequalities in here, this is an and. Okay? So ands are kind of sneaky. They're not going to tell you that they're an and. Ors are not sneaky at all. They're going to come right out and tell you, oh, I'm an or. If you don't see the word or in there, that's not an or. Okay? But if you don't see the word and, then it will be an and. So they're tricky. Ors are not. So this could be written differently. So method one is to take this and split it up into the two parts. What are its two parts? Well, first of all, cover up the 23 over here and just do 8 is less than 3y minus 7. You just do that part. Then cover up the 8 part and you do 3y minus 7 is less than or equal to 23. So those are the two parts, and again, this is an and problem. So when you split it up like this, you probably want to put the word and in there to remind yourself. So this is what this really means. Okay, so you could do that, split it up, and then you just solve each part separately like we've done before. So I'm going to go plus 7, these cancel. 8 plus 7 is 15, less than 3y. And then the last step is we want to get rid of that 3, so I divide by 3. And so what I have here is that y is greater than 5. Now it's backwards, so what I'm going to probably do here to make it a little more clear is I'm going to write, since y is on the big side there, I'm just going to write the y first. Y is greater than 5. That's the same thing. And then we do the same steps over here. I'm going to do the plus 7 first, just like I did on this side. 3y is less than or equal to 30. Divide by 3. So y is less than or equal to 10. So we've solved both parts separately, and we would say here that y is greater than 5 and y is less than or equal to 10. Well, what would its graph look like? So here's our graph. Here's 5, 6, 7, 8, 9, 10. And we've got greater than 5, no equal sign. Since something is missing from the sign, the equal part is missing. The filled in part will be missing, so that's why it's open. Here, everything's there, less than and the equal to, nothing's missing, so on that one we're going to fill that in. Can't seem to get that filled in with that thing, without that thing popping up. So that's filled in. Less than means it's going to go to the left of that one, and greater than means it goes to the right of that one. So that's what your graph is going to look like. So that's your graph. Now remember in section 1.6a, we talked about interval notation. How would I do the interval notation for this? Okay, let's look at the two parts. On the left side, we've got the open circle. Okay, there is no equal sign there. It's just greater than. So we're going to write it as a parentheses. And then where's that end part? The end is 5. And then where's the end on the right? It's 10. And since that's filled in, remember when it gets filled in, we use the bracket. So this is how we would write our answer in interval notation. Okay? All right, that's method 1. Now, I'm going to do a different method. We're going to get the same answer. But in this method, you may like it better. It could go more quickly. It might be a little more confusing, but it might go more quickly. I can just solve it all at once without splitting it up. Okay? So I'm gonna get rid of the 7. And to do that, I have to do plus 7. Well, in order to get rid of that 7, I have to do not 2 sides, but 3 sides. I have to do everything, do it to the one in the middle here to cross it out. I have to do it to the right side and to the left side. So I'm doing it all together. So 8 plus 7 is 15. 3y, and then 30, okay? And then the last step is I want to get rid of that 3, so I divide by 3. Well, in order to do that legally, I have to divide by 3 over here, and I have to divide by 3 over here. What does that leave me with? Y is less than or equal to 10, and y is greater than 5. So this is how my answer would look doing it with this method 2. It means the exact same thing that we did before, where we said y is less than or equal to 10 and y is greater than 5. It means the same thing. And as a matter of fact, our graph is going to look exactly the same. You've got 5 and you've got 10. On 10 it's a filled in circle. And on 5 it's an open circle. And y is less than 10. So it's going this way. Be careful on this one because it's switched, but you kind of have to read it backwards because y is kind of in the middle here. Y is on the big side of 5, so y is greater than 5. Don't get confused by that. So that's your graph, which is exactly the same graph we had a second ago. And in interval notation will be exactly the same thing. 5, it's not equal to, so it's going to be a parentheses, and then the 5. And then the 10 is the end over here. And since it's filled in, it's going to be a bracket. So exact same answer, but that's the second method. It might go a little more quickly if you understand that. It can be more quick. If it's kind of confusing to you, then just split it up first. Okay? All right, the OR compound inequalities. Let's take a look at those now. In order, if you have an OR compound inequality, it's true if one of the parts is true or the other or both. It does not need to overlap. Okay, so As long as one of them are true, we're going to graph it. So let's kind of do what we did before. I'm going to do the blue and the red separately. And so let's start out with, are we doing blue here first? So on the blue one here, okay. Well, rats, I didn't redo the numbers here, but I think we can figure out where the numbers are. X is greater than or equal to 5. Well, if this is 3, 4, 5. Here's 5. It's equal, so it's going to be filled in. And it's greater than means our arrow goes to the right. All right, let's switch to do the not the yellow, the red. So we'll go to the red here. And you know, again, I don't have this labeled correctly here, but we can figure it out. So 0, here's 0, -1, -2, -3 is right here. That's going to be an open circle. And if x is less than -3, that means it's going to go, arrow's going to go that way. So by themselves, those are the two graphs. They don't overlap. If this was an and, there'd be no solution because it doesn't overlap. But since it's an or, we're going to graph both parts separately together on that last line. Okay, so they do not have to overlap. So let me go to get black here. And so what I'm going to do is this red one, I'm going to graph it just like I did before. And the blue one, I'm going to graph it just like before. So the combination of the red and the blue is just basically we're graphing everything we possibly can. We're graphing the blue and we're graphing the red. So all together it would look like that. And so, and in this case, if we were going to write it in interval notation, here's how it would look. We would take a look at this part down here and we say it's going to -infinity. We always have parentheses with any infinity, and then here at -3 it's open, right? So that means parentheses. Since this is an or, that means it's a union. You do the little symbol, the U symbol, and then, you know what, I jumped the gun there, so I'm going to erase that. Because why am I erasing that? If you said it's a filled in circle, you are correct. And so, oh, sorry there. So since that's a filled in circle, we have to make that a bracket. And then that's going to be at 5. And then it's going to the positive infinity. And again, those are always parentheses. So written in interval notation, it would look like that. And so just remember, it's the union of the two inequalities. So you're just, as I say there, it'll include both lines. You're going to graph everything you possibly can. Doesn't matter if it overlaps or not. And if those two lines happen to be going together, if instead of going apart from each other, if they go together, it's going to keep going. They'll just keep going in both directions and fill in everything. And so we'd say all real numbers. Okay. So if ands go apart from each other, it's no solution. If ors go together, it's all real numbers. Okay, absolute value inequalities. Let's look at a few things here. What does absolute value mean again? It means how far away it is from 0, right? So when we said absolute value of x equaled 3, that means it was either at 3 or -3. Okay, because that's 3 units away from 0. But when we have something like this, we have absolute value of x is less than 3. That means that the distance away from 0 has to be closer into 0 than 3 units, either way. So it has to be either closer into 0 from 3 in this situation, or on the negative side it has to be closer into 3, which means it has to be greater than -3. So if you look at this, you know, if you look at the two parts here, It has to be closer than 3 units both ways. So what does this, if I were to kind of fill this in here, what kind of a graph does that look like if I were to connect these? That looks like an AND graph, doesn't it? That's correct. Okay. So what this really is, there's two parts to this AND graph. One part says it's basically just we have x is less than 3, exactly what's written here, but without the absolute value bars. And since it looks like an AND graph, we will write AND x is what? Well, look at this one over here. It's greater than -3. So this is how this would work out. X is less than 3 and x is greater than -3. One thing to keep in mind here, a little kind of a tip here that can help you to remember. How do we know it was an AND? How would I have known that that's an AND without having looked at the graph here? Well, here's a little trick. Look at the original sign here. That sign is less, watch out here, than. Look at that, less than. So whenever it's less than in your original problem, it's an AND. Less than and. Okay, less than and. So when we work something out here with absolute values, less than is an and the two parts it'll split up. Remember when it was an equation, we just did equal 3 and equal -3. Well, this is kind of like you know, I talked about Star Wars, the good side and the dark side. Well, this is kind of like the super secret double dark side, as I like to call it. You take and you not only switch 3 and -3, but you have to switch the less than and the greater than. Okay, so that's why there's two things that you're switching on these. And then if you were going to write this in interval notation here, look at the left side. It's at -3. It's open, so it's not equal to, so it's going to be parentheses -3. And the other side is at 3. The end is +3, and that's also a parentheses because it's equal. So in interval notation, it would look like that. What about this one here? It's greater than. Well, that means the absolute value has to be farther from 0 than 5 units. It has to be further away than 5. Okay? And so here's 5. It's not equal, so I'm going to make it an open circle, and farther away means it's going to go that way. 5 units in the other direction is -5. I'm going to put an open circle, and it's going to go away from 0, so it's going to be like that. Well, what kind of graph does that look like? That looks like an OR graph. We just did an OR graph a few minutes ago. So what are the two parts here? Well, the first part over here on the right is exactly what's written here, but without the absolute value bars. X is greater than 5. That's this part over here. And then since it's going away from each other, it's an OR. And then what about this part here? X is less than -5. So that's what the solution would be there. Here's how you can remember. How did I know this was an OR without looking at the graph first? Well, okay, remember our less than? Look at this part. Great OR. Huh? So greater, less than, and. So less than and greater or. Okay. So that's kind of how you can remember that. And again, on this one, how we would write this in interval notation is look at the left side here. It's going to infinity. Infinity is always a parenthesis. Whoa. Okay, that was weird. It's always a parenthesis, so I've got a negative infinity. And then 5 on the right. It's not equal to, so that's a parenthesis. This is an or a union, so we're going to do the U. And then parentheses because it's there's no equal there. 5, and then it's going to a positive infinity. And again, parentheses. The infinities always have the parentheses. So it's going to look something like that. All right, let's look at a few examples. I know this one's a little bit longer, but let's look at a few examples, and then there's one more thing to finish up after the examples. All right, example 1. I've got to solve this. All right, So first of all, I have to split up the absolute values. So my two parts here, 2x minus 2 is greater than or equal to 4. And greater means or 2x minus 2 is super secret double dark side less than or equal to a negative 4. So notice what I did was I wrote it exactly like it was without the absolute value bars, switch the inequality sign and the negative positive sign. Now I'll solve both of these separately. So plus 2 to cancel that out, plus 2. Now I have 2x is greater than or equal to 6. Divide by 2. And x is greater than or equal to 3. Or, then the other side here gets the same steps. So we're going to do plus 2 first. 2x is less than or equal to, this time, negative 2, because negative 4 plus 2 is negative 2. Divide by 2. And you get x is less than or equal to negative 1. So when we solve it, we get this. X is greater than or equal to 3, or x is less than or equal to negative 1. What's that going to look like on the number line here? Here's negative 1, 0, 1, 2, 3. Greater than or equal to means we fill it in. And greater than means it's going to go to the right. Greater than or equal to, so negative 1, we're also going to fill it in. But less than negative 1 means it's going to go to the left. So our graph is going to look like that. The arrows are going away from each other. What would that look like in interval notation? It's going to infinity to the left, so parentheses, negative infinity. On the right, it's filled in, so we have negative 1, but since it's filled in, that means it's equal. We're going to go with a bracket. Since it's an or, remember or is union, and so we're going to do the U. And then we have the 3, but it's also filled in there, so another bracket, and then the 3. And then it's going to the positive infinity, because the arrow keeps going to the right. Those are always parentheses. So it's going to look something like that. Okay? Here's another example. Example number 2. We're going to do the same thing here, except this time we've got a less than. So before we even start, less than, what's this going to be? An and or an or? Yeah, that's right. It's going to be an and. Okay, good. All right, so first of all, negative 2x minus 10 less than 6, and negative 2x minus 10 is greater than or equal to negative 6. Remember, we have to flip both parts, the equal sign and the negative sign. Now we just solve it. This is stuff that we've been doing before, so from here it shouldn't be too bad. We do plus 10 to cancel out the minus 10. So now I have negative 2x is less than 16. Divide by negative 2. By the way, what are we doing right now? We are dividing by a negative. What do we do when we divide by a negative? When it's an inequality? We have to flip this sign, so it's no longer less than, it is now greater than. Remember that rule from before? It still holds true, okay? It still holds true here. Divide by a negative, flip the sign. And that's going to happen on this side too. So we're going to do plus 10, plus 10. These cancel. Negative 2x is greater than 10, and negative 6 is 4. Divide by negative 2. Whoop, we're dividing by a negative. So this is going to be x is now less than a negative 2. And of course this is an and. So here's our answer. How's that going to look on a graph? Here's negative 8 way down here. Negative 2 will be up here somewhere. Less than negative 2, not equal. It's an open circle. Less than means it's going this way in the middle. Greater than, no equal sign, open circle. Greater than negative 8 means it's going to the right. So it's going to be all these numbers in here since it's an and. Okay, so that's what our graph is going to look like. And then written in interval notation. What's the end of the graph? The end is at negative 8. And since it's open, not equal to, it's going to be a parentheses, negative 8. And what's happening on the right? negative 2, also an open circle, which means a parenthesis. So interval notation would look something like that. Negative 8, comma negative 2 with parentheses. Okay, look at all the stuff going on here. Just like when we did the equations, we have to clear everything away from the absolute value bars before we can split it up into the two parts. And so we're going to have to get rid of the negative 8 here and the 6 first. So we have several steps to do on this one. So I'm going to do plus 8, plus 8. So I still have this 6 out here. Remember, we will not... Oh, man. This is not supposed to happen. Remember, we will not distribute the 6 here through the absolute value bars. And then 34 plus 8 is 42. In order to get rid of the 6, do not distribute it, divide by 6. So the 6's can cancel. Divide by 6 here. So now we have absolute value of 4p plus 2 is less than 7. Now we've got it to the point where our other examples were, and so now we can split it up. So we've got 4p plus 2 less than 7, less than, and 4p plus 2 is we switch both parts. So it was less than, so now it's greater than a negative 7. And we solve each part separately, so I'm going to go here minus 2 to get rid of the plus 2. 4p is less than 5, and divide by 4. So we have that p is less than 5/4, and minus 2, minus 2, minus 2. 4p is greater than negative 9. Divide by 4, divide by 4. So p would be greater than negative 9/4. And so this would be our answer here. Whenever you get fractions like this, go ahead and when you go to graph them, kind of running out of room here, but go ahead and turn that into a mixed number, or just divide it out on your calculator there. And so I should be okay with this, I think. Let's start with negative 9/4. 4 will go into 9 2 times, and 1 left over. So it's going to be a negative 2 1/4, somewhere about right in here. Just get it close. Open circle because it's not equal to, and it's greater than, so it's going to go this way. And then I'll put these in here so you can see where we're at. Just past negative 2. And then there's 1 and 2. And 5/4, 4 goes into 5 one time with 1 left over, so it's 1 1/4. So it's going to go a little past 1. It's also an open circle, and it's less than, and so we're just going to fill in everything in between there. So that's what our graph would look like. And again, in set builder notation, or not set builder, interval notation, at the left side here, it's 5/4. It's not equal to, so it gets a parentheses. On the right side, it's negative 9/4, and it also gets a parentheses because it is not equal to. All right, couple things here. Caution! Couple of things that could happen. First of all, look at this one. Absolute value of 3p plus 5 is less than negative 5. Now you might be tempted to go ahead and work that out and do 1 is less than negative 5 and 1 is greater than positive 5. But think about this for a second so you can save yourself some work when you see this. Absolute value of 3p plus 5 always has to be positive, right? Absolute value always has to be positive. So whatever number is on the left side, no matter what comes out of there, can you ever have any positive number that's less than a negative 5? No. Every single positive number will be greater than negative 5. So that, what we've got going there, this cannot happen. We cannot have a positive number less than negative 5. And so no solution. Okay, or you could say empty set, you know, where you do the a little thing like this. So no solution or empty set, you'd say there. That saves you some work. You don't have to go through the whole thing to find out that they don't overlap. You know right away it's a no solution. Let's look at another one. What about if you have absolute value greater than or equal to a negative number? Well, again, remember what's going on here with absolute value. That's always going to be positive. No matter what number I get out here, it will always be positive. Well, every single positive number that I know of is greater than -4. So in this case, what happens? It's all real numbers. Everything works. Okay, every single number works. So if that happens, don't go through all the work. You're just wasting your time. But pay attention. These are a couple things to watch out for. All right, last thing we've got here. Writing an absolute value inequality when they give you a graph. All right, remember what we said before when I kind of started the whole thing with absolute value? I said absolute value is how far away something is from 0. So when I look at this graph, I go, well, this graph goes out to 4 in both directions. Well, how far away from that is 0? In both directions, it goes 4 units. So I said, well, that would be the absolute value of x is, now is it closer to 0 or further away from 0? It's closer into 0 than 4, so we would say less than, and since these are filled in circles here, we say less than or equal to 4. So you kind of have to work it backwards a little bit. You say that the absolute value of x has to be less than or equal to 4 in a situation like that. Now, what do you do in this last one here? Ooh, this is a little trickier because before they were 4 to the right from 0 and 4 to the left from 0. Here, they're like the middle part here, it's not 0. That's a little tricky. Well, here's what happened here in this previous one that you probably didn't realize, but technically what happened here was this. Technically what happened here was the pattern is that you would say x minus whatever's in the center, in this case it's 0, would be, in this case, less than or equal to 4. How far away these two things are from the center. So this number in the middle here is whatever number's in the center, and this number is how far from the center. So that's the pattern is this. Now, in this case, why did we do this? Well, 0, we can just drop it because it's 0. So that's why it ends up being like this over here. Well, let's follow the pattern here. What do I have? Absolute value of x minus whatever is in the center. What's in the center of the 0 and the 6 here? 3. So I'll put 3 in here. And then in this case, is it closer into the middle or further away? Well, the arrows are going out, so it's further away. So we're going to say greater than. Do we put equal? Nope, because these are open circles, so no equal. And then how far away are these circles from the middle? 1, 2, 3. So we'd say greater than 3. So in this case, what we would say here is absolute value of x minus 3 is greater than 3. So that's just kind of the little pattern you go through there when you're given a graph and you need to write an absolute value inequality. Okay, so the center number goes in here, and then the number out here is how far away these dots are from the center. All right, well, that'll do it. I don't know what the time is on this one, but I think this was a little longer. Sorry about that. A lot to cover in this section. But thanks for sticking with me and going over this, and we will see you soon. Thanks.